Welcome, Form 4, Add Maths, Past Years, SPM. SPM 2013, topic Quadratic Function. Diagram 6 shows the graph of quadratic function fx equals negative brackets x minus 2 square plus 3k, where k is a constant. Now, the moment you see this quadratic function, you realize that it is in the form of complete the square. And complete the square has the form of y or fx equals to a brackets x plus b square plus c. In this complete the square, the number outside the bracket c is actually the y coordinate of the maximum or minimum point, and that y coordinate of the maximum minimum point is also the maximum minimum value of the quadratic function. And to get the x coordinate, you go inside the brackets x plus b, make it 0, you will get x equals negative b. And this is the x coordinate of the maximum minimum point. And don't forget, and this x coordinate, x equals negative b, it is also the equation of the axis of symmetry. And we know axis of symmetry, whether the graph U-shape or N-shape, axis of symmetry, it is a vertical line that goes through the minimum point or the maximum point. Now we continue with the question. Given that H12 is the maximum point, I've already denoted here H12 maximum point, and I'm labeling it the x coordinate and y coordinate. We look at what is the question asking. Part A. Find the value of h and k. Part A. They're asking h, they're asking k. Now the trick is, if they're asking h, go to the information regarding h. They're asking h, you go to h, which is the x coordinate of the maximum point. So h, I go to the coordinate h, which is the x coordinate of the maximum point of the quadratic function. So I copy back the quadratic function, which was equal to negative brackets x minus 2 square plus 3k. And if you remember, I said just now that go inside the brackets x minus 2, make it 0, and from x minus 2 equals 0, you transfer the negative 2, you get x equals 2. And this x equals 2 is the x coordinate of the maximum or minimum point. And we already have the x coordinate of the maximum point h. So this x coordinate of the maximum point is h. Therefore h is 2. Next, they are asking k. I go to the information regarding k, which is outside the brackets in complete the square. As I said earlier, in complete the square, outside the brackets is the y coordinate of the maximum point. Y coordinate of the maximum point, I go to the maximum point, and the y coordinate is 12. So this y coordinate is 12. So therefore I have 3k equals to 12. I transfer the 3. I have k equals to 12 over 3. Therefore k equals to 4. So I finish part A. We look at part B. What is the question asking? Part B. Find the value of P. Find the value of P. Now first of all, we have to go to the graph. We go to the graph, and you notice P is the y-intercept. P is the y-intercept. So now, when we go to the graph, we find that the P is the y-intercept. And we know from lower secondary, in y-intercept, the x-coordinate must be 0. In y-intercept or on y-axis, x-coordinate 0. So I go to the equation of the function that was already given, which is fx equals negative brackets x minus 2 square plus 3k. And this fx, of course, is the y-coordinate. The fx is the y-coordinate. And since p is y-intercept, the xp 0, xp 0. And earlier part, we already got the k. Earlier part here, that the k was 4. I'm going to substitute the k 4. So now, the fx is the y-coordinate of p equals minus x-coordinate is 0. I substitute 0 minus 2. Don't forget the square. Plus 3. And I substitute the k with 4. So now I have 0 minus 2 is negative 2 square, which will give us 4. But don't forget, that's outside negative. 0 minus 2, of course, negative 2 square, positive 4. But there's a negative outside, which makes it negative 4. And here, of course, 3 times 4 is 12. So now, our y-coordinate of the P is negative 4 plus 12, which is 8. So the y-coordinate of P is 8. Therefore, the P is 8. Okay? Thank you. I'll see you on the next lesson.